Hello all. Today we'll understand what is data warehousing, what is data warehouse, what is OLTP mission, what are the uses of OLTP mission, and what are the limitations of OLTP mission. Right? So let's start with data warehousing. So what is data warehousing? Data warehousing is a process or a technique implemented on corporate data to integrate and analyze data for decision making. So basically, this is a method which speaks about how to build the data warehouse and how to load the business data into the data warehouse and how to use that data for the purpose of analysis. Right? So, data warehousing is a technique which speaks about how to build the data warehouse and how to load the data into the data warehouse and how to use the data for the purpose of analysis. So, what is data warehouse then? So, data warehouse is built-in database where we'll load the data into the data warehouse for the purpose of analysis, right? And data warehouse is a centralized repository of data which is created by integrating data from one or more sources. So basically, if there is a business, there might be many business units. So collecting all the data from all the units of the business and integrating them together and loading it into the data warehouse, right? So data warehouse has the data which belongs to the enterprise business, and the objective of data warehouse is forecasting the business. So how do we forecast the business? So if you know what has happened in the history, we can forecast the business. How do we need to proceed in the future, right? So if you want to know what has happened in the history, we need to have the history data so that we can analyze the history data and forecast the business. So here in the data warehouse, we have all the data available and we see what has happened in the history of the business regarding the business and then take the strategic decisions on the business, right? So before going further and understanding more about data warehouse, let's understand about OLTP. So online transactional processing system. So what is this mission and why is this system used for, and what is the difference between OLTP and data warehouse, right? So let's understand first what is OLTP mission. So OLTP is a system which is built to run the business. So basically this system is built for the uh, for doing the transactions on the business. So let's see a small example how the system is really helping the business in doing the transactions, right? So in the previous days when we have a bank account, so we don't have a facility where we can directly go to ATM and withdraw the amount, right? So it was different in the previous days. So in the recent days, we have a facility where we can go to ATM and do the transaction, right? So let's assume I have an account in a bank. So I go to ATM, and immediately after I go to ATM, I'll use my ATM card, my debit card, right? So when I use my debit card, so what is actually happening internally, right? So when I use my debit card, so this ATM machine is going to communicate with the OLTP machine which is created by the bank, right? So these banks will be maintaining the OLTP machines, which in these OLTP machines, um, the account holder's information will be loaded, right? So when I use my debit card and when I use my debit card, so this ATM machine is going to communicate with the OLTP machine, and based on the information available on my debit card, it's going to pull the information available in the OLTP machine, right? So once it pulls the information from the OLTP machine, it's going to validate the password which is provided by the user through ATM and other information. So after it validates the information, it will allow the user to do some particular operations like money withdrawal, or you can change the password or take the mini statement, etc., right? So you can do some transactions on your account, right? So let's say I want to withdraw 2000 bucks, right? So when I say withdraw 2000 bucks, ATM machine will dispatch the amount 2000 bucks, and it's going to update the information in the OLTP saying the old information which was fetched, right? So that will become the old information, and it will insert a record saying now the available balance is 3000 bucks. right? So this is going to insert this information into the OLTP machine, right? So this way we'll be able to do the transactions on the OLTP machine. So OLTP machine is helping the users to do the transactions, right? It's helping the business to run more efficiently, right? So let's understand. So now we know OLTP machine has all the information of the account holders. So why can't we do the analysis directly on the OLTP machine? Why do we need one more machine by name data warehouse? Right? So there are some limitations on OLTP machine. Let's try to understand what are the limitations, right? So because of day-to-day transactions, OLTP will be filled up with data, and this data should be taken as backup. And OLTP should be freed up for further transactions. So basically, if there are many users, many account holders doing the transactions on OLTP, so there is a possibility that the data in the OLTP will grow in size, right? So it will grow more, and data and the data in the OLTP will be piled up. So when there is no space in the OLTP, users will not be able to do the transactions on it. So transactions may become slow, or users may not be able to do the transactions at all, right? So the data in the OLTP has to be taken as backup so that we can do the further transactions. So which means you cannot keep the data in the OLTP forever. So it has to be taken as backup, right? So this is the one limitation why we cannot do the analysis on the OLTP machine. So when the transactions are happening on the OLTP, analysis cannot be done. So if there are 100 users doing the transactions on OLTP, is it possible to do the analysis? Because the data in the OLTP is volatile now. So every user is able to change the data in the OLTP machine. So when I give a query to OLTP machine and fetch some information, right? So that is not constant across all the query runs, right? So let's assume I'll give a query to the OLTP machine to know how many users are available in Dallas, right? So it gives me a number saying 200,000 200,000 users. So after 2 days, if I give the query on the world TP machine, it gives me different information because there might be more users added, or there might be more account holders added, right? So it may give me a different information. So I cannot do the analysis on world TP machine when the transactions are happening, right? And next is multiple OLTPs can be designed for a business. If so, analysis on the business cannot be done, right? So let's assume uh, ICICI Bank. So uh, it has operations in India, it has operations in US, and it has operations in London. So let's assume it has operations in three countries. So it will build an OLTP for India in Oracle database, and it will build an OLTP for London in Teradata database, and it will build a OLTP for US in mainframe database. So there are three different databases where ICICI Bank has built its OLTPs, right? So there are three different OLTPs in three different environments. So I'll not be able to, analyze the data, analyze the business on all the three together, right? So those are the drawbacks of OLTP system, and why do we need um, data warehouse, right? Now, see here in this picture. So we have three OLTPs built for a business, and the data from the OLTPs are extracted, transformed, and loaded into the data warehouse. And from the data warehouse, using OLAP tools, business analysts are analyzing the business. Right? So this way, the entire data warehouse cycle will be processed. Right? So let us see the data warehouse life cycle. Right? So there are three major life cycles: dimensional modeling life cycle, ETL life cycle, OLAP life cycle, right? So dimensional modeling more speaks about how to create the data warehouse, how to create the tables in the data warehouse, how to how to create the data warehouse basically. So analyzing what are the tables that has to be created, what are the columns that has to be included in the tables, and what are the relations should be given to the table. So basically building the data warehouse, right? So dimensional modeling will speak about building the data warehouse, and ETL lifecycle will speak about how to load the data into the data warehouse. So extracting the data from the source systems, transforming the data into the proper format, and loading the data into the data warehouse. And then OLAP cycle will speak about how to read the data from the data warehouse and generate the reports, which will help in the help in analyzing the business, right? So so there are two major types of tables available in the data warehouse. One is dimension table and other is fact table. So when building the data warehouse is built with two types of tables. One is dimension table and next is fact table. So let us see what is dimension table and what is fact table. So before understanding what is dimension table and what is fact table, let us see what is normalization and what is denormalization, right? So here in this slide, I have a table which is built for a school. So if you see the structure of the table, I have student information and teacher information as well. And if you see the data, see the teacher information is duplicated in all the records. So since the table structure is having both the informations together, the teacher information has duplicates. There is data redundancy here in this table, right? So if there are 5 records available in this table, assuming there is a teacher who attends around 200 students. So if I have a table structure like this, so each teacher information will be duplicated 200 times, right? So this is called denormalized data. So if there are data duplications, if there is data redundancy, it's called as denormalized data. So let's see how we can normalize it. So see in this slide, I have two different tables for school data. So I have a student table and I have a teacher table now. So whereas the teacher ID in the teacher table is becoming primary key and the teacher ID in the student table is becoming foreign key. So with this primary and foreign key relationship, I can split the tables into two and I can have the data and reduce the data redundancies. So if I want to know who is the teacher for this particular student, I can do a simple join and I can fetch the data, right? So this is called normalization of the tables, right? So this is denormalized table and this is the normalized table. So now let us understand what is dimension table, right? So if there is a business, so there will be many subject areas for a business. So let us take few subject areas for a business. So if there is a business, there will be a product, there will be a customer who will buy the product, there will be a store where we will sell the product, and there will be employee who will be working in the organization, and we can take the time which speaks about when do you sell the product, right? So let's take these 5 as the subject areas of the business, all right? So for each subject, each major subject area of the business, we can build the dimension tables. So the dimension is something like in which, through which subject area you wanted to see the business. So here there is an example for product dimension. So basically from product dimension, if you want to see the business, see there is a product dimension built, whereas each and every information about the product is recorded in this dimension table. So dimension table will have the descriptive information of the business, descriptive information about this subject area of the business. So basically this dimension table, product underscore dimension, is speaking about subject area product of a business, right? So it will have all the details of this particular subject product. So I want to see the business from the prospect, from the dimension product. So I have to build a dimension table for the subject area product, right? So that is dimension table. So dimension tables will have the descriptive and detailed information about the business in it. And fact table, right? So fact table will have the facts of the business. along with the primary keys of the dimension tables. So here in this slide you can see product ID is the primary key in the product dimension table, customer ID is the primary key in the customer dimension table. Same way store ID and date key as well. So there is only one fact available in this fact table by name units sold, right? So only units sold is the fact here, and remaining are the keys of the dimension tables. So all these keys together can be considered as primary key in the fact table. So all these four keys can be called as a composite primary key in this fact table, right? But individually, product ID is the primary key in the product dimension table, and customer ID is the primary key in the customer dimension table. So fact table will have the facts of the business along with the primary keys of the dimension table, right? Okay, so now we know that now in the data warehouse there are two types of tables available. One will have the descriptive information and other will have the facts of the business, numeric information, right? So let us see the architecture of the data warehouse. See, fact table. So there are two types of architectures available in the data warehouse. One is star schema and other is snowflake schema. Now let us see what is star schema. A star schema is a schema where a fact table will be surrounded by the dimension tables like this. See, a fact table will be surrounded by the dimension table like this. So dimension underscore customer, so it has the information about the customer, and dimension underscore time, it has the information about the time, and store, it has information about store, and product, it has the information, it has the details about the product, right? And all the keys of the dimensions are available in the fact table along with the facts. So unit underscore cost is a fact here, and product underscore sold is also a fact here, right? So this is how star schema looks. Fact table surrounded by the dimension tables, and the dimension tables are denormalized dimension tables. So when the fact table is surrounded by the dimension tables and the dimension tables surrounded are denormalized, then it's called as a star schema. So let us see snowflake schema now. So snowflake schema also looks similar to the star schema, but only difference is here the dimension tables are normalized and splitted into one or more dimension tables, right? So here also fact table is surrounded by the dimension tables, but the dimension tables are normalized and splitted into one or more dimension tables. So this is the only difference between snowflake and star schema. So based on this one particular difference, we can, you know, so there the data is denormalized in star schema, right? So which means more data redundancy. Here in snowflake schema we have normalized tables, which means data redundancy is less. So in star schema, less number of joins because of less number of tables. In snowflake schema, more number of joins are required because of more number of tables. So basically, when more number of joins, query processing time to pull the data will be more. So we can have, you know, these many differences because of one this particular difference, normalization and denormalization, right? So next is about data mart. So we know data warehouse where we save the data of the enterprise business. So data which belongs to the entire business will be saved in the data warehouse. But what is this data mart? See, the data mart is a subset of enterprise data warehouse in which can be used to answer the questions of middle level management. So which means, so the data mart will contain only the subject oriented data which will answer the questions of middle level management. So let's assume there is a sales lead. There is a sales lead uh, for bank ICICI, right? So there is a sales lead for bank ICICI. So all he needs is information about sales, right? So sales information he should be having. He should he needed only the sales information so that he can analyze the business on sales, right? So he doesn't need information on the entire data on the entire business, right? So this data mart will have the subject oriented data which will answer the questions of middle level management. So only information which belongs to sales has to be put in the data mart, has to be created uh, with the data mart. So the data mart has to be created with only information for a particular subject so that the decisions can be made faster. So let us see the approaches of data warehouse now. So there are two types of approaches for data warehouse: top down approach and bottom up approach. Top down approach is told by Bill Inman and bottom up approach is told by Ralph Kimball. So let us see what are these approaches. So top down approach tells about first build the enterprise data warehouse, then derive the data marts from the enterprise data warehouse to answer the questions of middle level management, right? So first build the enterprise data warehouse, then build the data mart for derive the data mart from the data warehouse. So this approach is a complex approach and more resources are required for this approach, and also cost wise, so project cost will be more with this approach. And next is bottom up approach, which is told by Ralph Kimball. So Ralph Kimball tells first build the subject oriented data marts and integrate all the data marts together to become the enterprise data warehouse, right? So first build the subject oriented data mart and then integrate the data marts to become the data warehouse. So here in this approach the decision making is fast and the project cost will be less. So the effective approach is bottom up approach, right? So this is all about data warehouse and data warehousing, right? So next is about ETL process. So we have seen how the data warehouse will be built, right? So now let's see what is ETL process, right? So we know from the OLTP the data will be taken as backup, and see the data which is taken as backup from the OLTP will be extracted. So extraction, transformation, and loading the data into the data warehouse. So extracting the data from the source system, transforming the data into the proper format, and loading the data into the data warehouse is called as ETL process. So ETL means extraction, transformation, and loading. Alright. So extraction, we know we fetch the data from the source system, and loading, we know we load the data to the target system. So what is this transformation? So this transformation is required because so when we are loading the data into the data warehouse, the data should be in one proper format, one particular proper format. It should not be in different formats. So if you say 100 records are in uppercase and other 100 records are in lowercase. So since the data in the database is case sensitive, make sure you transform the data into the proper format and load the data into the data warehouse, right? So this is about data warehouse, data warehousing, OLTP, data mart, and ETL. High level about ETL, right? So in next class we'll try to understand what is ETL process and what are the types of ETL process available and what is Informatica. Alright. Okay. So thank you very much. Thank you all. Have a good day.